Hey guys, and welcome to the transformation constraint tutorial where we go over exactly what the transformation constraint is. We talked about the tracking constraints and the copy and limit constraints, but we also have a particular very specific constraint here. I'm going to go into the bone constraints tab here, and I'm going to show you there is a specific transformation constraint here that actually has a very powerful functionality. It's one of the most versatile constraints in the fact that I would prefer to call it the transformation mapping constraint or the map transformation constraint or something like that to make it a little bit more obvious what it does. But basically, it's like the copy rotation or the copy transformation constraint, except you're not really copying something, but rather mapping the transformation to do something else. So this is a very complex UI here. As you can see, it might get a little confusing at first, but I'll walk you through it. It's pretty simple to understand. First things first, we want to use a target. So I'm just going to go ahead and select the cube here. And this cube will be our target. You can select whatever target you want as long as it's an object, or I believe you can also do a different bone and a different armature if you would like to do that as well, which will give you the sub parameter for the bone if you so choose. For example, like so, you would have to choose a bone here as well. But of course you can't have it mapped to itself. So we're just going to go ahead and use this cube here for ease of understanding. And so let's just go ahead and take a look at these examples. First of all, this extrapolate button, we're going to go back to this in a bit. But you have a source and you have a destination. So the destination is going to be the object that you have the constraint on. That is the destination of the mapping. So let's say we want to change the rotation of the destination bone. Well, by default, it might not seem like it's doing anything as of right now. As you can see here, we have the location moving and everything. Nothing is happening. We have the rotation. Nothing's happening, right? Well, that's because these values are by default at 0, 0, 0, 0, 0, 0, which means that it doesn't allow for any movement whatsoever. So this destination has a min and max value, kind of like the limit rotation or limit location or limit scale constraints. These are going to want to be changed to something a little bit more reasonable. If you just want to get started, I would just do a 360 for all of them just to make sure you have the full range of motion there, just to see what it looks like. So let's go ahead and take a look at that now. Of course, if you do this, still nothing happens. You're wondering, okay, well, I made it so that it could rotate freely. Why is it not rotating yet? Or why is it not doing anything yet, really? Well, if you take a look at this, the same thing happens. So this is interesting because we're looking at the source now. The source also has a 0, 0, 0, 0, 0, 0 limit, a range right now. Let's go ahead and extend this a little bit so we can read that. Min max, well, that's exactly the same thing. So we have basically this min max value being basically saying that this cube is not going to be able to, you're not going to be able to read any values of this cube beyond 0. So that doesn't do anything for us. So we want to do, let's just do a 1, 1, 1. Right? Sorry, I just did a 1, 1, 1, 1. Let's do a 0 to 1 for each one of these. 0 to 1, 0 to 1, 0 to 1. And now, let's see what happens if we move this cube. Hypothetically, if we just take a look at this, it says here it's a mapping, right? We have source to destination mapping. We are taking the location of the source and then mapping it to the rotation of the destination. So this is something that you can do with the transformation constraint that you can't do with the other ones, with the other constraints. So let's go ahead and take a look at how this looks. If I move this, you'll notice the guy is now rotating. The actual bone is rotating along its own z-axis as I translate this cube along the z-axis. You can also, of course, use the x-axis. As you can see here, there we go. That's the range at which it's moving. It's moving a full 360 degrees, but it's only moving when the cube is between the values of 0 and 1 along the x-axis. So that's pretty handy. As you can see on this side, it's negative. You can see that on right over here in the location parameter, you can see that I move it this way, it's negative. So when on this side, it's going to be positive 0 to 1. And then, of course, we do the y-axis as well, and it does exactly the same thing. So you can actually move it along these axes pretty well. But, of course, it's limited to that range, which is pretty, it might not be super useful. So one thing that's super cool is you can actually just click this extrapolate button, and all of a sudden, it will work no matter what the range. It actually will work beyond that range and extrapolate the same sort of motion, the interpolation between the location past the range of the cube's limitation, as well as the destination's limitation. So this could actually be 1, 0 to 1 degree, 0 to 1 degree, and it would still it would still work. Now, of course, this mapping, these values determine essentially the coefficient of the transformation. So the coefficient being the scalar of it, the factor of influence. So of course you also have this influence bar globally, but if you have this thing and you want to say, if I basically, what you're saying is, if I move this object by 1 blender unit, then you will want to rotate this object by 1 degree. So we had it at 360 earlier, which is a little bit more reasonable in terms of being able to see the difference, so that when you move it 1 blender unit, it'll already rotate 360 degrees. Now if we change this to 1, you'll notice, just 0 to 1, 0 to 1, there we go. You'll notice that it takes a lot longer for it to even show any kind of movement, but it does work. So that's one way to change that coefficient of the transformation, essentially. The difference between those two numbers. Now, this can be applied to location, rotation, scale. You can have the rotation actually just do it. Of course, you do need to have this thing actually working. So we're going to do 360, 360, 360, and of course, change that to 360 as well. Copy, paste. Then we have the 360 mapping. So now that's just basically a copy rotation. Basically a copy rotation transformation constraint. Of course, you can also do scale, which is pretty cool. We'll do a min of 1. Let's try a min of 1. Let's do a max of, say, 10, right? And then you have the rotation suddenly is mapping to the scale of the bone. So look at this. It's a very strange looking transformation, but it is actually extremely powerful considering you're just taking one value and mapping it to another value of another object. So that is the transformation constraint. It's very versatile, very, very useful for rigging because you can use it to drive bones with other bone properties and even objects with other object properties. Again, you can also use this constraint in the objects constraints tab for transformation. So if I took another cube, actually, let's not do that. Let's do an empty object, right? Let's do an empty object, a planes axis. Let's just have this axis be the new source, and I'll just go ahead and click that. And then now that this empty is the transformation source for this cube, so you can take let's say the location of this, and you can even map things very easily like with this as well, just by multiplying the change here. So as you can see, the cube actually ended up really far away, and that's because it's multiplying all the transformation of this by 10. So let's bring that down just a little bit. I'm just going to do like I don't know, 1.5. How's that? I'll just copy that over. 1.5, 1.5. So now it's just like 50% more transformation than the empty there. Now this guy no longer has the location driving anything. So if we just change that to location, so you'll see here now that this object, this empty object, actually drives the cube to be 50% more than the object's transformation, and then the bone will be driven by the object's transformation. Pretty cool constraint, very useful, and I hope you learned something.